This is a assignment to analyze the Jubilee hospital heating plant energy usage after they have upgraded the heating plant. First thing to do, using Retscreen Plus, type in project name, then location Vernon, BC, prepared for Retscreen workshop by me, and this is for video recording. Now we're selecting climate data location, type in Vernon, select Vernon, search. This is Vernon. Then now select location, drag it to the site, select the climate. You'll automatically come here, the nearest climate, which is ground, not NASA. Okay, click yes, and you see Vernon appears. Next thing is data collection. So we need to collect the data. There's only one fuel we're analyzing, and that's gas. So import, assignment 1 is import heating plant historical gas usage. Type 1 fuel consumption, locate natural gas in gigajoule. There you have it, and now we're going to import the data, import from file. Activity version 2. Now, you're not going to import, oops, this is beer, and this is Vernon Jubilee Hospital. Okay, so we're going to import column B and column C, not column A, so we do not import column A. Okay, so that's it. Take note of the format, day, month, year. Okay, click yes. Natural gas gigajoule, make sure this is in sum, aggregate method. Okay, so we have got the data imported. The next thing we're going to import, what is driving this natural gas? It's weather, right? Weather is driving the natural gas. So click on weather. And we need to import the weather for this location. Download NASA satellite data. Okay, when did the data begin? We didn't notice that. We go back to natural gas. You see it started 2001-02, so which is 2000 January of 02. Okay, so let's start 2000 January 1st. Go back to weather. January 1st until the present. Okay, so we are downloading data from NASA. Okay, missing data 6 means there were 6 missing data, and what they did is just average it out to fill in the gaps. Okay, software automatically average out those missing data, 6 of them. Now we don't need all of the information here, so we're going to hide quite a few of these columns. All we need is the average air temperature. Okay, so we take out minimum temperature, maximum, relative humidity, daily solar radiation, atmospheric wind speed, earth temperature, and comments. Okay, period here refers to day. This is a day by day reading. So what we need to include now onto this data for weather is the degree days. So click on degree days and reference temperatures. So degree day we are assuming is 16 degrees. Balance temperature is 16 degrees. Balance temperature is temperature at which there is no requirement for heating or cooling. Balance temperatures where there is no requirement for heating or cooling. So it's assumed to be 16 for now. Okay, so we have the heating degree days here. Okay, now the next thing we want to go on is develop. Assignment 2 is develop regression. Okay, select the driver, which is the weather, right? Okay, then develop the regression. So now we need to import the heating degree days to the natural gas data table. So we'll need to import we need to merge. Okay, so destination is natural gas, source data table is the weather from Vernon. What we need is heating degree days. Okay, that's what we need, heating degree days. So we've got the data added on. So now we're going to develop the regression between, which is the relationship between the natural gas usage and the heating degree days. Okay, so let's go on to analytics. Establish baseline. Regression analysis. So now we're establishing a baseline. Natural gas, heating degree days, independent variable is heating degree days on the x-axis. The dependent variable is natural gas. So the driver is heating degree days based on the balance temperature of 16 degrees. The method is daily. If you need to know what daily means, go to help. Go to help. Here. Oh. Okay, doesn't work at this point. Okay, daily, just take daily first. Well, the explanation was we have to use daily rather than duration because we are mapping from a daily temperature reading to a monthly gas usage reading. So we want the daily reading to be taken, a 1-for-1 reading. So in that case, the monthly daily average will be assumed to be a daily average. Alright, so the monthly natural gas consumption will then be divided to daily consumption. Okay. So we have the regression analysis. This is the relationship between natural gas and heating degree days. So what it means is that for every single data, so what it means that from 01 January to 01 31st, heating degree days was a total of 772 heating degree days, and the amount of gas used was 767. So what they've done is they've added up the heating degree days, 772. Okay. Then the heating degree days is likely divided by, I'm just guessing here at this point, 772 divided by duration of days (30) 26. Okay, so it looks okay. And the second one, (661) divided by number of days is 28. 23.6. Okay, so that's what it's done. It's taken the total of degree days in that month, January, divided by number of days to give you the average of 26 degree days, heating degree days for that month. Similar with 661. Total of that month from the weather data divided by number of days in that month, 28, and you get 23. And the gas is averaged out per day to 256, 238. So let's take a look at the gas. 7675 divided by 30, we get 256. Okay, correct. Same with this guy, 6890. 6890 divided by 28, you get 246. I get 238. Okay, how did that happen? Maybe it's 2090s. First, second, 2090s. Okay, 2090s. 661, no, 6890. $237.5, so 238. All right, correct. All right, so what is mapped onto this chart is actual natural gas per day used, 238, and heating degree days. So 23 you would see somewhere around here 23 heating degree days would show up as 238. 02, 29, yeah, here it is. Yeah, see that? 2002, oops, disappeared again. 2002, 0209, 23203, 23203 predicted. Oh, okay. All right. Okay. So that's how we get the regression. Regression is fairly accurate here. Perfect is 1. This is sort of like indication of how accurate this regression is, or how good the relationship is. So R-squared in that sense is pretty good. It's 0.9156, very, very good. So 1 is perfect. Okay, 1 is perfect. All right. So now find out the QSUM. The QSUM is cumulative sum of gas used. All right, so we type onto this, and this is end-to-end QSUM using all regression. Okay, end-to-end QSUM. All right, so what it means is that the baseline was established in the regression in the previous chart. All right, baseline being this baseline, and using that baseline we got this, and then we charted the gas used, cumulative gas used. All right, so you can see that the gas being used compared to the baseline is increasing over time. Okay, then later on, because of something we did, some changes at this point, change in boiler system, for example, that we encountered then a reduction in gas used. It starts going down. Okay, the cumulative sum starts going down until it goes below, meaning we are actually saving. Okay, we are actually saving. If using the past regression we had just, all right, we are actually saving gas. Okay, so now the value of gas is going down and down and down further. So the baseline from the 9-year duration was this, and then because we did something to the heating plant, we upgraded the heating plant, and the cumulative sum of the gas compared to the predicted value of gas used began to go down and down. Had nothing been done to the baseline, to the system, and this would have, if the system had no changes at all, then this would have been just this, the cumulative sum would have been around here. Okay, but because something happened. So what we are looking at is we want to develop a baseline that is before the change happened. The change happened here, so we want to develop a baseline that's starting from here. So select a point. Okay, select a point, say 0531, and or you could select somewhere around here, 0131. Okay, and create a new baseline all the way to for 10 months. Okay, yeah, 0131 and do it for 10 months. Okay, select it for 10 months. Okay, so now we go back to 0131 10 months baseline. All right. So click on that now, 0131. Duration is now for 10 months. Okay. So this is the regression, or the relationship between the gas and the weather before the heating plant change happened. Okay, so using that, now we notice there is a very good relationship again, 0.9266. Okay, very good relationship. Okay, then we want a cumulated sum based on this new baseline. And we can select this again. And look at that. So this new baseline before the heating plant was changed, and the cumulated sum went down and down and down and down. Okay, so that means had nothing happened to the heating plant, this is the predicted, this should be the cumulated sum. All right, where the gas just would hover around here. But because we changed the gas subsystem, the boiling system, so the supply, the cumulated sum of the gas used became negative, meaning we're actually using the less gas than the predicted, than the established baseline before the change in the heating plant. Now we're going to select a target based on best performance. All right. So in that case, we set a target. All right. This is a target based on best performance. All right. Okay. Then we want to measure measurement and verification. We click here to get measurement and verification. So at the point when remember the baseline is this period. So at the point when this baseline was established and ended here, then there will be a new, this is the predicted actual natural gas used, which we predicted should be lower, whereas the actual predicted baseline was this. Baseline predicted this. Okay. Baseline predicted was that. So baseline predicted was this. Okay, so this keeps going up and down. All right. Okay, now the next thing I'm going to do is go back to Kusum, and from here we want to select where is the best performance, okay, within this period after the plant was modified. So you would try to select one that's the steepest slope, because that means you get the best gas reduction in that period, right? Let's take something around here, okay? 2002-06-30. All right, 2002-06-30. So now we want to establish a new baseline based on 2002-06-30 for a year. Okay, so we do another regression analysis. Before we go to that, we want to optimize the reference temperature. Okay, so because 16 was the assumed balance temperature, so now we want to optimize the reference temperature. Click on this. All right, so the system will start optimizing the balance temperature. All right, so for this period of 10 months that we selected for regression, the system identified the best balance temperature for us. Okay, and one which, so in a way what it's doing is actually trying to optimize the best element. So it looks like it is 12. Okay, minimum is 12, maximum is 30. Okay, so we try to reduce again, go down to maybe around 15. Okay, okay, let's try it again, optimizing again. Yeah, so it is 12. All right, we try to reduce again, say let's go down to 10. Okay, all 9. All right, let's see what we get. Okay, can you go down further? Let's go down to 7. Oh, so it seems to be hitting a kind of peak here. Let's say we try to reduce it below 7 to 5. See if it works. You will see that peak. Notice that? So it looks like the best value is 7.5. All right, 7.5. So balance temperature is actually 7.5. Okay. Okay. So in that case, we now go back to a new regression analysis. Use 7.5. Excuse me, we have to figure out what period we want to use. And so let's say it is the best. What was the date that we selected just now? Okay, 2003-06-30. 2003-06-30. Okay. So we're going to establish a new baseline using 7.5. All right. We call this, oh, I forgot to do something. Delete. All right. Try again. So we call this target baseline. Okay, natural gas and heating degree days based on 7.5 degrees, balanced temperature. Okay, so that is the new regression line. Okay, based on 7.5 degrees balanced temperature and 2003 0630. June 30th. Okay, so let's do it for 9 months. All right, follow the 9 months after that. So notice the regression is pretty good, right? The relationship is pretty good. Okay, so based on that, we want to set a new target. Okay, that's our new target. Okay, because we got a new target, we can put a control chart, and that control chart tells us whether we are close. Okay, so we should not deviate a lot from this target. All right, we can go below, but we should not go above. Okay, so that is the target. All right, that is the assignment for Jubilee Hospital